Russ Bradley is a biologist on the Farallon Islands.
Most of the time that I've spent out there is in the spring and the summer in the seabird breeding season, where I work about 6 weeks at a time and then get a couple weeks off. We have over 40 different studies that we're working on with the seabirds that take us, from day into the night. We look at things like how animals survive, how they reproduce, what they eat, and how that changes through time, and what all that information can tell us about changes that are happening in the ocean.
Some of his most important work focuses on the Brandt's cormorants that live on the islands.
Brandt's cormorants are a diving seabird. They're distributed from Mexico all the way up to Canada, but the biggest single colony of Brandt's cormorants in the world is on the Farallons, which has been as highest about 20,000 birds.
Russ has been working on the Farallons for 10 years, and the past 4 have not been kind to these unique seabirds.
In 2010, we saw a slight increase in the breeding success, but basically for the last 4 years, we've seen very poor breeding performance for Brandt's cormorants, and we've never really seen that in a series of years like this before. We think that this, may be an example of some real changes that are occurring in the local marine ecosystem, and that there may be climate impacts that are causing shifts in the prey, the fish that the cormorants have been so successful on.
This has Russ and other biologists very concerned, not only for these birds, but for other nearby populations.
They seem to be a very unique indicator species of changes that are going on in the ocean. We've been studying Brandt's cormorants on the Farallon Islands for over 40 years. And we've seen in the last few years, the cormorants really seem to have a hard time reproducing their chicks, and it seems to be related to their food. And it appears that Brandt's cormorants are telling us about big changes that are going on with the so-called forage fish populations, the schooling fishes like anchovy, that we care about for lots of different reasons. So they're an important indicator of many different things.
One of the most exciting scientific findings of the past half-century has been the discovery of widespread trophic cascades. A trophic cascade is an ecological process which starts at the top of the food chain and tumbles all the way down to the bottom.
We all know that whales eat fish and krill, and some people, certain politicians in Japan for instance, have argued that killing whales is good for human beings, as it boosts the food available for us to eat. And so you would think. But as the great whales declined, so did the numbers of fish and krill. It seems counterintuitive. Surely their numbers would rise as their major predators disappeared. But it now turns out that whales not only eat these animals, they also keep them alive. In fact, they help to sustain the entire living system of the ocean. Whales feed at depth in waters that are often pitch dark, and then they return to the surface, to the photic zone, where there's enough light for photosynthesis to happen. There they release what biologists call fecal plumes, vast outpourings of poo, punamis. These plumes are rich in iron and nitrogen, nutrients which are often very scarce in the surface waters. And these nutrients fertilize the plant plankton that lives in the only place where plants can survive, the photic zone. Fertilizing the surface waters isn't the only thing the whales do. By plunging up and down through the water column, they also keep kicking the plankton back up into the photic zone, giving it more time to reproduce before it sinks into the abyss. Even today, though whale populations have been greatly reduced, the vertical mixing of water caused by movements of animals up up and down through the column of the oceans is astonishingly roughly the same as the amount of mixing caused by all the world's wind and waves and tides. More plant plankton means more animal plankton, on which the larger creatures then feed. In other words, more whales means more fish and krill. But the story doesn't end here, because plant plankton not only feeds the animals of the sea, it also absorbs carbon dioxide from the atmosphere. When eventually it sinks to the ocean floor, it takes this carbon out of circulation down to a place where it remains for thousands of years. The more whales there are, the more plankton there is. The more plankton there is, the more carbon is drawn out of the air. When whales were at their historical populations, before great numbers of them were killed, it seems that they might have been responsible for removing tens of millions of tons of carbon from the atmosphere every year. Whales change the climate. The return of the great whales, if they're allowed to recover, could be seen as a benign form of geoengineering. It could undo some of the damage we've done, both to the living systems of the sea and to the atmosphere.
In a society which is predicated on competition and really very often the ruthless exploitation of one human being by another, the profiteering of other people's problems, and very often the creation of problems for the purpose of profiteering, the ruling ideology will very often justify that behavior by appeals to some fundamental and unalterable human nature. So the myth in our society is that people are competitive by nature, and that they're individualistic, and that they're selfish. The reality is quite the opposite. We have certain human needs. The only way that you can talk about human nature concretely is by recognizing that there's certain human needs. We have a human need for companionship and for close contact, to be loved, to be attached to be accepted, to be seen, to be received for who we are. If those needs are met, we develop into people who are compassionate and cooperative and who have empathy for other people. So the opposite that we often see in our society is in fact the distortion of human nature, precisely because so few people have their needs met. So yes, you can talk about a human nature, but only in the sense of basic human needs that lead to certain traits if they are met, and a different set of traits if they're denied.
So, welcome to Mythbusters Virtual Reality. Reality. This is Adam, and no, however much you turn around, you won't see me because I'm not here. I'm just doing the narration. But the narration of what? Well, for Shark Week 2015, we tested the myth that sharks are scared of orca noises, killer whales, and we conducted that experiment on a shipwreck. This video is a behind-the-scenes tour of that wreck in full 360 degrees. So as we descend, you can already see the reason why we came to this wreck in the first place. There's loads of sharks. If you look all the way around you, you're surrounded by, I reckon, 25 sharks? These are nearly all Caribbean reef sharks, with the odd nurse shark thrown in. They're pretty hard to see. Now, I have to admit, I do get a little nervous before getting in the water with these guys, particularly when you're on the surface of the boat looking down into the water. Looks pretty scary, but once you're in the water, what you see is that sharks are beautiful, graceful creatures. It's a real privilege to be able to dive with them. But back to the wreck. This wreck that we're over now isn't the wreck that we filmed it. To be honest, I don't know what this wreck is, and it's so dilapidated it's actually hard to see what it might have once been. So enough already on that. The wreck we filmed in is the one just coming into view in the distance. Yep, here it comes now. Behind that diver who happens to be our executive producer, checking the place out prior to our experiments. You can see that somewhat predictably, the wreck is guarded by a bunch of sharks. Actually, not a bunch, a shiver. I think that is the collective noun for sharks. A shiver of sharks. I like that. It's better than a mouthful or a gulp or a tooth. No, shiver's definitely the best. So now we're swimming directly above the wreck, heading towards the stern. This particular boat was called the Ray of Hope. It's a pretty terrible name for a boat that became a wreck, lying on its side at the bottom of the ocean. Oh, cool, look. If you look straight ahead, you can see a large wrasse heading into that tunnel. Beautiful. But anyway, back to the story. This ship didn't have some kind of accident. No, it was sunk here deliberately to become an artificial reef. And over the last 2 decades, it has become colonized by all kinds. You can see stag coral sponges, sea fans. A huge amount of life has taken hold on this wreck. Now, because this is only 40 feet deep, it gets a lot of light, so it's a great place for coral to colonize. And it's because of this colonization, this diversity, that means an entire ecosystem complete with complex food chains and food webs can exist. And ultimately, what that means is that there are sharks. Lots of them. A shiver of them. Although, of course, at the moment I say that, I realize there's not any sharks to see at this point of the boat. Murphy's Law. We did this dive the day before our experiment as a kind of a recce, a reconnaissance mission, to get familiar with it and figure out how our experiment was going to go down. But to see how the experiment itself worked, if you dare, you need to check out our other virtual reality videos.
The St. Clair River, Lake St. Clair, and the Detroit River, also known as the Huron-Erie Corridor, are the international waters that connect Lake Huron to Lake Erie. Environmental changes in the corridor over time have resulted in a loss of habitat for fish and other organisms. This video is focusing on the successful St. Clair River Fish Habitat Restoration Project and the science and collaboration that made it a success.
We were so surprised that lake sturgeon found the habitat and were spawning on it even though it wasn't completely constructed. We wanted to make sure that the materials we used were suitable for fish spawning. We have been perfecting the habitat materials and determined that a certain size and shape of rock was important to maximize the space between the rocks. If there's too much space, the eggs could be washed out by the water. But if the spaces are too small, the eggs would not be adequately protected from fish and other organisms. The project team developed a plan and methods to build new spawning habitat to increase lake sturgeon, lake whitefish, walleye, and other native fish populations. We learned that water flow, water depth, and water temperature were all important in the placement of a spawning reef. Another important factor is the available nursery habitat downstream that is crucial for the survival of young fish produced on the spawning reefs. One of the most important components of these habitat restoration projects is the monitoring that we do before and after the reef is constructed. In this way, we know whether any fish were there using the area before we construct the reef, and we can document the success of our spawning habitat projects. This video shows that there were lake sturgeon eggs among the rocks and adult lake sturgeon in the area before the construction was even complete.
Human alterations in the system in the late 19th and early 20th century resulted in many changes. One of the largest was the result of widening and deepening for commercial navigation. In the Detroit River alone, a major modification in the lower river resulted in the removal of over 300 million cubic meters of limestone rock and other material from the bottom of the river. The result was a dramatic reduction of fish populations throughout the entire Huron-Erie corridor. In 2004, a collaborative group of university, government, industry, and non-governmental organizations established the Huron-Erie Corridor Initiative. The first two projects, one at Belle Isle in the Detroit River, the other at Fighting Island, also in the Detroit River, but in the Detroit River International Wildlife Refuge, have significantly improved fish habitat. And we've seen fish responding to our latest project in the St. Clair Delta while it was under construction. Fish habitat restoration is a key part of US EPA's strategy to restore impaired beneficial uses in the system. These restoration efforts will provide cultural and economic benefits, bolster commercial and sport fishing, and contribute to a higher quality of life for the people living in the corridor. All of these projects are part of our long-term goal to replace some of the habitat that was removed 100 years ago to support commercial navigation. The next steps for the partnership are to choose the restoration sites based on this model and build on our past successes. This is science in action, and this is the kind of research project where we're not just performing research to learn about new things, but we're applying the results for the benefit of the larger community. Our approach in the Huron-Erie Corridor is a potential model for success for other locations. We're making sure that our work builds on the science that has gone before, so we're learning and adapting as we move forward.
The Huron-Erie Corridor is the epicenter of fish populations and fish habitat restoration in the central Great Lakes. The fish spawning habitat restoration successes in these connecting channels can have positive impacts on Lakes Erie and Huron, as well as the entire Great Lakes Basin. The Huron-Erie Corridor Initiative partners will continue to work together to manage, restore, enhance, and protect the living resources and their habitats in these connecting waterways.